Hi everybody, welcome to the Modern Analytics Academy Data Governance with Azure Purview session. I'm Brian Hitney, a Cloud Solution Architect with Microsoft. Thank you so much for taking the time to join us today. As a reminder, all of our content is up on the aka.ms/MAA site. You can visit the site, and within that content, we'll have a page for every session in the Academy. We're building it out as we go, so you'll see new things added over time, so please do check back frequently. Also, because it is in GitHub, we do recommend that if there's any changes you'd like to see, please feel free to open up any issues and then also issue pull requests if you have modifications or changes you'd like to see in the content. We do welcome that feedback. Let's take a quick look at the team. We've got Alex, Annie, myself, Chris, and Jason. All of us have been contributing to this repository. And the sessions that we have so far, we have the acquisition and storage session, data modeling, data pipelines, data governance, which obviously is this session, and the next one will be on visualization with Power BI. So looking at the agenda for today, we're going to talk about what data governance is. We'll get into the components that make up Azure Purview, spending most of that time doing demos, and finally we'll get into the cost and scale behind Purview. Now when we're talking about what data governance is, we're not going to spend too much time doing that in today's session. We do have additional content that will be in the Purview page up on the MAA site that I referenced earlier. There we'll be able to dive a little bit more, spend more time talking about data governance and the framework and the people and the processes that are needed to implement an effective data governance strategy. But for the purposes of this session, we won't get into it too deeply. So looking at the definition of what is data governance, well, my favorite is the one in the middle from Wikipedia, that data governance encompasses the people, the processes, and the technology required to create a consistent and proper handling of an organization's data across the business enterprise. I like this because specifically mentions the people, the processes, and the technology. An effective data governance strategy is going to need all of those, and you'll see that when we get into Purview, quite a bit of it is focused on the policies, the processes, and also the people associated with a data governance framework. When we talk to chief data officers, one of the most frequent things we hear is the struggle to maintain balance between compliance and data discoverability. So with compliance, we're looking at things like security of data, controlling access to that data, what's the risk exposure of data, are we compliant with regulations like GDPR, but also because data is likely the organization's largest asset, how do we make sure that that data is discoverable and usable by people within the organization? And so it's a challenge, and that's something that the data governance framework is designed to help solve. So what's in a data governance framework? Well, it starts with our data, which can often be in the edge with our devices. It could be in the data center, it could be in one or more cloud providers. And the data itself has a life cycle where it is either created or ingested, moved throughout any number of systems using ETL and ELT processes, ultimately is archived or destroyed. And so within our data governance framework, then, we have the people that we've identified as experts and managers and stewards of that data. We have the processes defined that control that data movement. We have policies that can do things like apply classification rules or data retention rules, and then the technology that helps implement all of that. So when we look at the roles and responsibilities in a data governance framework, this is an example of some of the questions we'll ask. Who's maintaining a business glossary? What kind of policies do we have on accessing the data? How PII data is managed? How do we ensure that customer data is consistent across the system? So basically data quality. And then we'll also look at classification schemes. So when we have individual pieces of data, for example, how are we going to label that? What do we determine to be, say, public data, data that might be for internal use only? Within the organization, it might be confidential, sensitive, restricted, but then also data retention. So is this something that is short-lived data that should be deleted after a short amount of time, or is it something that should be held on permanently? So this is an example of classification schemes that it's important that we have defined in a data governance framework. So there are a few key goals that the team had in mind when developing Azure Purview. The first is the ability to manage and govern all data, whether it be transactional or analytical data, to be completely cloud native as a fully managed PaaS service, and to eliminate manual ad hoc homegrown solutions. Another key goal in establishing the foundation for effective governance is to automate the discovery of data, whether that be on premises, in Azure, or in another cloud, to be able to classify all of that data to specify sensitivity, compliance, and then also be able to track the lineage of that data. So basically the data lifecycle, where it started, how it got transformed throughout the process, and where it ended up. Of course, a goal too is to maximize the business value of data, allow users to be able to quickly find data, view its lineage, classification, sensitivity, and then also have a place where we can store curated list of glossary terms so that everybody within the organization has a clear understanding of all of the terms and the meanings within the business. And finally, we need to gain insight into data across the entire estate, and that means understanding how the data is created and moved, to be able to understand what type of data we have, the sensitivity, to understand the lineage, and we need to do this visually in order to assess the entire organization. So let's take a look at the components of Azure Purview. There's the data map, data catalog, and data insights. The data map is the heart of Purview, and that's what manages all of our resources and data connections throughout our organization, whether they are on-prem or in the cloud. It also manages all of the metadata, the classifications, the lineage, so it's essentially a large graph database. This is exposed to the data catalog that allows us to discover and interact with the data. And finally, there are the data insights that allows us to assess how our data is used throughout the organization. Let's look at this in a little bit more detail. The foundation at the bottom consists of the data map that stores all of the source metadata. So where our data assets are, how that data is classified, any associated lineage, so if the data is transformed throughout multiple systems, the data map will maintain that lineage. The data map exposes an API based on the Apache Atlas 2.0 standard, so we can write custom code as needed in order to fit a specific use case or build a new interface. The data catalog is how business users interact with the data, allowing users to search for or discover assets. We'll be able to see how that data is classified and visually see the lineage of the data, view business glossary terms, people associated with the assets like subject matter experts and business owners. And finally, the data insights, providing details into the data estate through a single pane of glass in order to get a better sense of the data estate. While the data map provides access via the Apache Atlas 2.0 API, Purview integrates with Power BI, Synapse, Microsoft 365, and also has third-party integration such as with Prophecy's MDM. So now that we see what the key components of Purview are, let's switch over to the Azure portal and take a closer look. So here I am in the Azure portal, and I already have a demo account created. It'll take a few minutes when we spin one up, but we'll click create a new Purview account. We'll go through that motion here so you can see what it looks like. I'll create a new resource and we'll do a search for Purview. And the page comes up, we'll click create. And just like many of the other resources in Azure, we can give it a subscription that we're going to put this in. The resource group, typically we create a new one, Purview account name, and then also a resource group name for the managed resources. Really the thing I wanted to call out here is if you've looked at Purview previously, or if you've read any of the documentation that might have been when Purview was in preview, as it was recently GA'd, you'll see that the way it is built has changed slightly. So the default now is that a Purview account will have one capacity unit, which is equal to about 25 operations per second, which is essentially a read, write, update operation on the data map. And then it's also provisioned with 2 gigabytes of storage. So as our needs grow, if we have a lot more throughput demand or an exceptionally large data map, for example, then this will auto scale to accompany that. We'll get into that a little bit more when we talk about the Purview and how it's metered and priced. For the most part, that's all we have to do in order to create a basic Purview account. What I'll do is I'll click on the Purview Studio tab here, which once we have the Purview account created, we can see all of that within the Azure portal, but just like with Synapse and Data Factory, there's a Studio experience that wraps all the functionality together. So here in Azure Purview Studio, I've got a sample account, and by the way, this demo, I will have a link for it within our Modern Analytics Academy data governance site, so we'll have this as one of the resources in there. So you can go through and create actually everything that that you'll see here. So within Purview Studio, we have the default page here is the data catalog view, and we can see along the left, if we expand this out here, we see that we have data catalog, data map, insights, and management. So these are the four areas that we can dive into. Most of the time, we'll spend that time in data catalog because that's where our data discovery, classification, and such happens. The data catalog is populated off the data map, so while we're starting out and adding our resources and scanning them, we would probably be living in the data map section quite a bit, and so that's where we'll go ahead and start. So when we go into the data map page, one of the first things you'll see, assuming we're in the map view like this, is we'll see a graphical interface of our data estate. This is going to start with a root collection. Now, my Purview account here doesn't have too friendly of a name, but that's okay. It's we would rename that with something more friendly for our organization. And then within our root collection, we can have any number of collections or data sources directly. Typically, we would break this down to whatever makes sense for our organization. So in this case, we have a sales collection, and then we have a marketing collection. That might not be appropriate for every organization. They could be broken down by business group, by geography. So you might have a North America collection and then business groups within North America, for example. So really the idea with a collection is that it's a logical grouping of resources within that, and those collections can also contain sub-collections. So however it makes the most sense is how you would lay out your collection. So in this case, we've got a sales and marketing collection. We can also look at the collections here by switching from sources over to collections, where we'll see a hierarchical view of all of the collections. In this case, the root, we could see all the number of assets within it. I could drill into and see the marketing, which has 10 assets in one data source, and also the same with sales. One of the things you'll see within each collection is that we can configure the role assignments for that collection and any collections underneath it. So that allows us to basically cascade these role permissions down based off of whatever your organization might look like. So to do that, we'll click on role assignments. And one of the things you'll see here, once we go into, in this case, the marketing role assignment, is a number of different role assignments and then the people who are associated with those roles. So the first one is collection admins. So collection admins is a role for all users who basically are doing what I'm doing here, which is assigning other roles and working within collections, who might be setting up new collections, adding people, changing the collection details, and so forth. So as the name implies, that's going to be the folks who are administering the different collections. The data source admins, those are the ones that manage the data sources and also set up the scans of those data sources. The interesting thing here to take note of, though, is that a data source admin by themselves doesn't have access to Purview Studio. So if you're a data source admin, you actually would not by itself be allowed to come into Purview Studio. You would have to also be a data reader, which is a little bit further down, which we haven't gotten to yet. So typically, most data source admins would also be data readers. We have data curators. Data curators, they are the ones that they have access to the data catalog to manage the assets, to configure, delete assets. So basically read-write permissions on the data map and those assets, being able to apply annotations, classifications, and so forth. And then finally, data readers at the bottom. These very similar to a data curator, except all of their permissions are read-only to the data map, so they can go in and browse all of the resources. So this would be the most frequently used by the users in the organization who are trying to browse and understand the data estate. So let's go back and look at the sources again. So here again we have our collection, our sales and marketing collection, and notice then within each collection we have a single data source. So under sales we have the Azure SQL database, and in the marketing we're using an Azure Data Lake storage account, and within each one we're connecting to that data source, and we can look at the details within them. Essentially, if I click view details, we'll see that for our data lake storage we have one scan associated with that. We've discovered 46 different assets and we've classified 2 of them. And then we can also see the recent scans, how long they ran for, any details associated with it if they failed, and then also the hierarchy associated with this scan. So if I click on the scan name, we could see when it was run. It was a manual scan, and when it started and how long it ran for. In this case, about 7 minutes or so. And this is important to understand where this is, because how we set up the scan, including the rules that we apply with the scan, is going to impact how long it takes to run. So if we're scanning potentially a huge data estate, then tuning this might be important to keep in mind for performance considerations. So if we click Edit Source, you'll see that it gives us the name, the subscription, the account name, and so forth that it is associated with. The next thing is that we'd like to set up a new scan for our data source. Now in this case we already have one scan which is sufficient for this data source, but depending on the size and the type of data source you're connecting to, if it's a large data lake for example, you could have potentially multiple scans associated with it. It really depends upon what you need. So if we click on New Scan, the first thing you're going to see is it's going to ask us for a name and then an integration runtime that we're going to use to connect to. Now, the default here is the auto resolve integration runtime. This actually is the only integration runtime that I've got configured here in my Purview account. We could use other integration runtimes, for example, if we want to connect to an on-premises data source that is not publicly accessible. We could use then a self-hosted runtime in order to essentially proxy that connection, so we can still index things that are outside of Azure and not able to be connected to from the auto-resolve integration runtime. And then a credential that we're going to use in order to connect to this data source. In this case, I've already had this connection to this data source set up using the managed identity built into Purview. So what that would require us to do is there's a help here that will walk you through this the first time. You would go over to in this case, the data source, which would be the data lake account, and you would configure the RBAC rules for the Purview managed identity in order to read it. We can do the same for our SQL Server. We can also set up a username and password, assuming we're storing that password in Key Vault. So there's a number of options we can pick for how we wish to authenticate to our data source. And we'll click Continue. It will automatically, by the way, test the connection to make sure that it works, of course, because here we have to be able to tell it what we want to scan. We could see if we go into the data lake storage account that there's a folder called Bing that has 4 folders, and then a data folder, which obviously as we'll see here, has a structure for date and the various files. So if I go over to Storage Explorer, I have this account already opened here. This is the data lake storage account, and in the blob containers Bing, you can see that here are the 4 files that it found. This is all part of these files are in the open source repo in GitHub. And then the data folder, if we dive into that, we could see that we've got the data is broken out by year, and then these separated TSV files, tab separated value files, queries by country, and then queries by state, and then a group by year. So we could see that here, and we'll click Continue to go through, and it's going to ask us now for a scan rule set. Now, by default, every data source has a default scan rule set that's built in. In this case, it's using the ADLS Gen 2 system default scan rule set. So what the scan rule set does is it determines how to look at the data. In this case, for a data lake, it wants to know what kind of files to look for and what kind of patterns to match in those files. And so it's going to use the built-in rule set in order to do that. We can click View Detail to see what that rule set looks like. In this case, you can see that there's a whole lot of different files that are associated with this rule set. Everything from CSV files to text to Parquet and so forth. Even binary files, PPTX, PPS, PDF. Because really, this isn't about just data ingestion and movement, right? This is about data discovery, and a lot of that data is going to exist in these binary assets. So the ADLS Gen 2 rule set supports all of those file types. That may or may not be appropriate for your organization. There could be perhaps a need to not look at certain files because you know that you're only scanning, for example, for CSV or Parquet files, and you want to explicitly ignore zip files, for example. And then also the rule set will tell us which classification rules to apply. So classification rules is, as it's looking at the data, it's going to try to match what it sees in the data to known rules for classification purposes. So is this a phone number? Is this an email address? Is this look like a social security number? Those kinds of things. It's going to try to apply all of those rules that are built into the system. So this is our opportunity where we could create custom classification rules and then also a way to scan for certain files. So if we do this, we could click a new scan rule set, give it a name. So for example, I could say this is a custom rule set. We can then configure which file types, and we can either add new file types or use the default ones. Let's just assume for the sake of argument that we're only interested in maybe a few different file types. And then the rules that apply. And this is where we're going to want to balance the idea of data discovery, where we might think we know what's in these files, but we also want the system to be able to discover data that we didn't know that we had. So we want to balance being thorough by allowing it to see all the different possibilities, but also bear in mind that the more rules that we apply, it's going to impact the scan time. So again, if I knew exactly the scope of what are in these files, maybe there's absolutely no government specific rules that apply. Well, we could dive into these and look at them, but if we knew that that was not in there at all, we could deselect it, and that would help the scan time proceed a little bit faster. We could also create our own custom classification rules. So if we want to create a custom classification rule for a particular order number or something like that, we can do that. In fact, we'll take a look at that in just a moment once we move through this. And then finally, the last thing we can do is set up an ignore pattern, where if there's certain files we want to ignore, we could just give it a regular expression here of which types of files to ignore. I'm going to cancel this for the time being because this scan by default will pick up everything within that folder just fine. I do want to go back to something we talked about, which was the classification rules. Here under classifications, we can see all the built-in system classification rules. We can also create custom ones. So I created a custom classification here just by clicking new and then creating custom classification. Once we have a custom classification, then we can create custom classification rules however we'd like. So in this case, let's look at creating, I have one in here already called order ID. In fact, what we'll do is I'll delete this and we'll create this one. And we'll recreate it to show you that process. So what I'll do is I'll say new and we'll give it the same name, order ID. And we'll give it the belongs to our custom classification that already exists. And when we're creating a new classification, we need to tell it how to classify, whether we're going to use a dictionary, which would obviously be if we know all the possible values. Maybe it's a true, false, or a month name, something where we could provide all the values. We could upload a dictionary, or we could give it a regular expression, which is more common when we're trying to match against data. So perhaps data that we're storing can't be matched by the built-in classifier because of the way we're storing it, right? Maybe there's a social security number without hyphens that it's not finding, or something to that effect, or we have a specific format to our data. So we'll click regular expression, and on this page we could specify a regular expression that matches our data. So let's take a look at what that might look like here. I'm going to go over to, I've got this sample orders .csv file that I have created just for this demonstration, and we could see what that looks like. In fact, let me zoom in on this a little bit. So I created something very small, again, just to illustrate this point, but suppose we have a simple CSV that has a date, and it has a custom order number, and maybe in our business an order number has an alphanumeric character right here, W, followed by, say, 6 digits as part of the order number, and then maybe the total. And that first character can be maybe a W, an S. It kind of depends on the source that it comes from. And so by default, I don't believe there's a rule in Purview that would necessarily pick this up as order ID. So we'd like to create one that matches. So what we can do is I can upload that file by selecting, say, sample orders And what it's going to do is it's just going to look at that file that we upload. It's going to try to see what the column names are, assuming the columns are in the first row. And then it's going to build a regular expression that matches what we see in that data. So this is really handy because I don't know about you, but regular expressions, I know how they work and I can build them, but I do it infrequently enough that I almost always get something wrong. And so you forget a caret or a bracket or something somewhere. So this is a handy way to have the system take a good guess at what your data might look like. So we could see here that it's going to start with a character, alphanumeric, or an alpha character A to Z, followed by 6 numerical values to make up our order ID. And so that seems right based off the data I put in there. I don't see anything wrong with that. And then the minimum match threshold, typically we recommend about 60%. This will help account for anomalies or nulls, things like that. If we bump this up too high, like 100%, then if there's one anomaly or something in the row, then it won't be classified as an order ID in this case. If you do it too low, then you risk getting false positives. So 60% is about the recommended best place to start. And then a column pattern is going to be called order ID. So if we see a column named order ID, we'll know to match that as well. And we can finally test that and see how it applies to a data set. So that's a quick look at how we can create a custom classification and classification rule. The other thing that we should point out too within scan rule sets is the idea of resource sets. So if we go back and look at the data lake, you could see here that this data is broken down into in our data folder by year, right? We have 2020 and 2021, and then we have queries by country and queries by state that have the specific date values built into the name itself. So this is a pretty common pattern that you would have in a data lake. So for example, we might have a pattern that looks something like this, right? Where we have orders raw, and then typically, let's just say a year, month, day, and then you would typically have maybe a file name with, again, the date as part of the file name.csv, and then maybe another order the next day, that kind of thing. So this is a very common pattern in a data lake. And so what's important in Purview is so that it understands specifically all of that data is really part of the same collection, right? So if we get down into the data lake, queries by country should be one asset that is made up of all of these files. We don't want to see n number of queries by country files. And so that concept, that's called a resource set. Now by default, the data lake or scan rule set accounts for that because it has matching patterns to know to look for days and repeating names and so forth. We can customize that with pattern rules. You can see this is grayed out by default. We can enable this under management over here by enabling advanced resource sets. Currently it's off because the built-in scan rule set does a great job at matching that for us, but that is something customizable. So if we have a fairly unique naming convention in our data lake, we could come up with a pattern, as long as we can develop a pattern for it, which most likely exists if it's some process that's writing data into the data lake, that will match all of those files for us. So once all of our scans are configured, we could do the same and look at our Azure SQL database. If we click on the details here, we can see that we've had one scan. We discovered 17 assets and classified 15 of them. Typically, we would want to be able to scan at least once for each data set. We'd probably want to set this up on a schedule, which we could do when we configure a new scan. We can either have that run once manually or set it up on a schedule, and that's typically how you would do it. You would have a schedule that might run daily, it may run weekly, and they could either be full or incremental scans, so we don't have to spend a lot of time going over data that we might have already looked at. Now what we'll do is we'll go back, and now that we've got our data map set up, remember the data map feeds the data catalog, so we can take a closer look now at the data catalog and look at the data that the scans have brought in. On our data catalog page, you can see at the high level we've got the number of data sources that we have configured, the number of assets, and also the number of glossary terms. Then a search bar and a way we can just browse through the assets. We can manage the glossary here The glossary is essentially a way that we can manage business-specific terms that we could then apply to our data assets. This is really important because every business that I've seen has some kind of just internal jargon or labels that they use to describe data that may be unique. It could even be unique to a specific business or group within the organization, and sometimes it's throughout the organization. And so it's important to have this lexicon defined in a place so that everyone's clear as to what it means. So for example, is a term like revenue, does that include tax? Is it net? Is it gross? We want to be able to define all of those things, and within the glossary is exactly where we would do that. We could see that there's a whole number of built-in terms, but we could also create our own and also bring in, if we have a file someplace with all of our glossary terms, we could import them in mass as well. And so this way, it's a way that we could describe and tag our various assets with these descriptions to clear up any potential misunderstanding of what something might be. And we could import those terms here. If we look at any particular one, for example, adjusted meeting hours is a term that's built into the glossary. Gives us a definition, an acronym. It could give us related terms where we can come up with synonyms, related items, but then also context. Now in this case, we don't have any context associated with this, but very often, especially if you're creating custom glossary terms, there are two types of context. There's experts, which are your SMEs or subject matter experts who are able to answer questions about how something is built. So if we, for example, have something called revenue, who could provide the details as to specifically how that is calculated, and then also data stewards who are responsible for understanding that data and the flow of that data, that we can also reach out to understand the impact that that data has across the organization. So here we can either now search our data catalog if we know we're trying to find something, or we could browse our assets. One real handy way to search the catalog is just do a search for star. And what that will do is it'll also bring up this filter pane where we can filter by any of the collections, classifications, contacts if they happen to be associated, or labels that might apply, glossary terms, and so forth. So it's a handy way to drill down into your catalog. Now in this case, we'll look at, say, everything in the marketing section. We can see that we found all the files in our data lake and our queries by country. Now notice that the resource set applied here, right, where even though we have multiple files, this is a single entity here that's made up of all these files, and you can see that it matched the pattern here of all these files. We click on this and go in, we could see that we have an asset description, which I haven't filled out yet, any classifications, and then also schema classifications, which are specific so that within the data itself, are we finding any specific classifications belonging to the data. So if I click on schema, for example, we could see that there was the date, the query, an implicit intent, the country, and then a popularity score. And so it found the country and assigned it a classification as being a country or region. So again, as it goes through the data, it's going to scan it, see if it matches these kinds of things, so we can understand the kind of sensitive data that we might have in our catalog. The other interesting thing is to see that the data, a lot of these files are going to be labeled with, in this case, a confidential label. We could see that that is here after the file name. These are actually from M365 in the information protection section of the Compliance Center. If files are labeled a certain way of having, say, for example, top secret or confidential, having PII, however they happen to be labeled from Microsoft 365, those labels will stay with the data regardless of where it goes. So in this case, Purview will pick up on those labels and it stays here. Now currently there is no way within Purview to manually apply those labels. It has to happen from M365, and also Purview cannot remove or modify these labels in any way. It's currently a read-only thing that gets applied from M365. So let's go over and look at our sales. Our sales happen to have the Azure SQL database with the AdventureWorks database built on top of it, so we can see all the tables that are in there from customer, address, and so forth. So if we click on the customer table, for example, we'll see that it found an email address, a person's name, and US phone numbers within that schema. So if I click on that, We'll see all those columns and then the tagged classifications associated with it, as well as sensitivity labels, glossary terms, data types, and so forth. So this is really where we could spend a lot of our time as curators to make sure that these are accurately defined. So for example, suppose we had an email address, but we store it in a particular way where the classification engine did not determine it was an email address. Well, we can click Edit, come in here and change the custom level classification so that it matches whatever classification rule we set up. So if I have, this was not customer ID, but this was my order ID, we could add it here. We could select the custom, oh actually I think it was custom classification, there it is. And custom classification had the order ID, so I probably should name this a little bit better. But we could then select that customization, and now this column would be tagged with our custom classifier. And we could also apply any glossary terms and an asset description. And in this way, people who are searching the catalog later on have a pretty good idea of specifically what is in there. And also later on, when we're looking at the insights, we'll be able to see exactly where our sensitive information is and how we're securing that for compliance and security. Here too, we can go under the contacts and assign experts and owners simply by searching for their name. So if we know certain individuals are experts in this, I think Alex was an expert on our AdventureWorks LT, so I could do a search for him. There he is. Right, so he's the expert, and so we'll go to him with any questions with our customer table. Back on the data catalog page, if we don't want to search by star, we can also browse, which will give us a similar hierarchy that we saw in the data map, where we could see all of the collections and then drill down into any collections within them. So for example, clicking sales, and now we're here in this collection. Similarly, we can filter out our classifications, contacts, labels, and glossary terms. In this case, by source type, we can see that we've got several different source types within our collection. Data Factory, which we haven't talked about yet too much. We have our data lake storage account, SQL Server, and if we click on this, for example, we'll see that it just tells us which storage account is linked in our data catalog. And so there's a number of different ways we can drill down and get an idea as to what our data catalog contains and search it. So if we know, for example, if we don't want to just search star, but we know we're looking for customers or customer, we can enter that data, and then we can see that it will look and show us everything that matches that criteria, and then be able to select that. In this case, customer address is an Azure SQL table, which is related to, of course, the customer table in the AdventureWorks database, and then be able to see schema classifications associated with it. Okay, so that's a quick look at the Purview interface, creating the account and understanding the data map, how we add sources to that data map, how we scan them, and then using the data catalog to find and understand those resources. There's a lot more here that we want to get into. We'll do that in just a moment, where we'll look at lineage and then also understand insights and some other features. Let's start by taking a closer look at data sources and then data lineage. Within Purview Studio, on our data map sources view, we'll register a new data source. We'll see a list of all of the available connectors. This list is growing all of the time. And notice that some of these may be in Azure, they could be in another cloud, or on-premises. You'll also notice that some of these have the word multiple. We can use these to register potentially a large number of assets within an account. So if we had a large number of storage accounts, for example, we could register them all at one time instead of individually. Azure Synapse, by definition, may have multiple dedicated or on-demand pools, Spark clusters, and data lakes, so it will have the multiple indicator. I have an existing Synapse workspace in another subscription, so we will add that. I will keep the default name. I know that this Synapse workspace is in this subscription, and it's the only workspace within there, so I'll select it. In this case, I'm just going to assign it to the root collection and click Register. Now, by design, we cannot register the same data source multiple times in the same Purview account. This is to help to avoid the risk of assigning different levels of access control to the same data source. And as a best practice, if the same data source is used by multiple teams, we would want to register the data source at the parent collection, and then we could assign appropriate scans at each sub-collection. The other thing to note here too is we do not actually check if we have connectivity to this Synapse account. In order to verify access, we'll have to set up a scan. So to test that connection, we'll click the new scan icon, and we'll keep the default name and integration runtime. And it's a SQL database within Synapse, so we'll just select the right pool. As a best practice, you want to use the managed identity whenever possible. We could use the SQL authentication if we'd like to, but we'll stay with the managed identity. And then we'll click Test Connection. And we're going to see that this connection failed, so we're going to want to set that up within Synapse. So over here in Synapse, what we'll do is go under Access Control, and we're going to add the managed identity as a reader. So we'll click Add Role Assignment, find the reader role, and click Next. This is going to be a managed identity, so we'll add that. It's in a different subscription, so I'll just select the correct subscription in my case. It's within a Purview account, and it finds the Purview managed identity, and we'll just add it and click Review, Assign, Review and Assign. And now the Purview identity is in the reader role for our Synapse account. Back here in Purview Studio, it may take a moment for those permissions to propagate, so we'll try again. I've noticed sometimes you have to cancel and set up the scan again in order for it to refresh. There we go. Now once the report is generated, notice that it's showing me a warning, and we can view the report for more details. We could see that even though we have access to the Synapse account, we don't have any read access into the pool. So in this case, what the managed identity needs to do is to be able to go into the SQL pool in order to read the schema and the top few rows of the database in order to understand what kind of assets are in there. So to solve this, we'll go over to the Synapse Studio. In this case, we have the pool right here, and I've got already a query to add the managed identity from external provider. And then what we're going to do is add the managed identity as a data reader. And once that's done, we should be able to read everything. Okay, and now we have successful connection, and we were able to read the data within the pool. We can set up this scan to run either once or on a schedule. We'll have it run only once. Click Save and Run. And now the scan is queued for execution. This will take some time for the initial run. In the future, we can configure this to run as an incremental scan for better efficiency. We'll take a break here and move over to data lineage. When we talk about data lineage, we're referring to the life cycle of data within the organization. Data might be created, say, from sensors or transactions, and is often transformed in some way. So it might be summarized, it might be included in a visualization in a Power BI report, or it could be stored in a data warehouse. Data is often backed up, and eventually it might be purged, depending on the retention policies. The goal of Purview's lineage features is to help track the data as it moves through its life cycle, so this will allow us to better understand the flow of data and also see the impact that any changes might have. There are essentially three different ways we can work with lineage in Azure Purview. The first is with native support. This would include Azure Data Factory, Synapse Pipelines, Teradata, SSIS, Power BI, and list is growing all of the time. The next is with Apache Atlas hooks. Purview is built on top of the Apache Atlas framework, so when creating a Purview account, you may have noticed that an event hub is created automatically. We can send and receive messages to specific Atlas topics to support lineage and changes in assets. And finally, there's a REST API. We can use the REST API to support custom lineage, so they can be integrated into our processes. Let's look at a simple example. Earlier on, we looked at some files in a data lake that was created as part of our demo. This included the queries by country and also queries by state files. I'm going to switch over to Azure Data Factory, click Author, look at a pipeline just called Copy Pipeline. It has one task, and it's just a copy activity. What we're going to do is, if we look at the source, we'll see that we're going to take all of these files, and we're going to have a source sync. We're going to merge them. We can open this up and see we're going to merge everything into merge.parquet, and indeed if we go back to the lake, we can see that file here. So obviously a very simple example. Now in Azure Purview Studio, I will click on the queries by country file, and specifically in this case we're going to go over to the lineage tab. Now we can see here that the lineage for queries by country feeds into our copy activity and has the data into the merge.parquet file. If I want to pivot this and look more closely at the copy activity, I can click Switch to Asset. And now we can see specifically focused on the Azure Data Factory copy activity, the inputs and the output. A very basic example of how lineage works. Now let's look at a more complex scenario. For the next example, I'm going to switch over to a different Purview account. Here I've got my Purview demo environment that has a number of different data sources. I'll just click on my customer table. We can see that there's a few classifications, email address, person's name, phone number, and so on. But what I want to look at here is the lineage. We can see that this is quite a bit more complex than our simple example. We're focused on the customer SQL table, as indicated in the upper left. On the left side, we have a list of all of the columns in the SQL table, and on the canvas itself, we could see all of the processes and data sets. So let's zoom in on this a little bit. A square edge indicates that this is a data set. So we have the customer data set, which is in the SQL table, of course, and then a data set here and here. Everything with a rounded edge indicates a process. So a job, in this case, all of these, I believe, are ADF jobs. So maybe I'd like to see how customer ID and email flow through the system. So I can select those two columns, and we can see that they get added to the canvas and also show us where they end up in each data set. I can also toggle to show only data sets with all of the columns I've selected. So if I select that, and let's scroll over and look, we can see that this is grayed out slightly. You might not be able to make that out too well over video, but this is grayed out, so we know that in this case the customer ID and email address both are not appearing here, so I could ignore that in my search. If I unselect this, we can see that we have customer ID up here. So email address does not flow through, and this is actually a process that removes sensitive information and then copies it out to a data lake minus the email address. Further over, we can see a few things going on here. We could see one, that a process is marked in red that indicates an error of some kind. We could see that we have an additional process, and then we can expand this. What the canvas will do automatically is try to consolidate all of the processes and data sets down to make it a little bit more navigatable. We can expand these nodes out or hide other ones. So on binary copy, for example, I can click hide from canvas and have that shrink down. Likewise, we can expand it back up and see all the processes. On the process that's showing an error, I can click on this, and we could see that this is a data flow activity. There's a couple of things we could do. We could switch to this asset, and we can also open it in Data Factory. Now, in this case, you would need permissions to open this pipeline in Data Factory, which I do not have. So I will switch to the asset. And now our focus switches from the customer to the company data aggregation data flow activity in ADF. So now we can see the whole lineage from the perspective of this data flow activity. All of the data that flows into it, and then all of the outputs. Go back. I'll click a data set like our customer backup, and we can switch to this asset. Here too, this customer backup takes the data as a copy activity in ADF and stores it in our data lake. And we can see specifically the lineage as it applies for this customer backup, where it flows from the customer table, gets aggregated down into a customer, and then eventually into customer backup in blob storage. Now in this case, all of these processes that we've looked at are leveraging ADF. It's important to remember that if we had custom scripts or jobs running that do not natively support Purview lineage, we could integrate them with the REST API to report lineage. We'll have these resources up on the aka.ms/maa site, but there's a number of resources to look at for more information. The first is, of course, up on docs.microsoft.com. A number of tutorials on publishing messages to and from Purview's Atlas Kafka topics. Also, a tutorial on using the REST APIs. And there's also, from Will Johnson, a CSA at Microsoft, a PyApache Atlas project that you can use and implement into your own solutions. So next up, let's look at some Purview data insights. So far, we discussed the data map, which is the core of Azure Purview, as well as the data catalog. Azure Purview Data Insights is another feature that provides a single pane of glass view into the data catalog. And with Data Insights, there are several reports that we can use depending on the kind of information we're looking for. So let's go over each of them, and as we do, remember that Data Insights is still in preview, so we may see some changes. First, we can navigate to Insights from the left nav in Purview Studio under the Data Catalog and Data Map. From there, we'll see the different Insight panes, intended to help users across a variety of roles to quickly understand their data estate at large and gain key insights, such as where sensitive data resides. The first insight is called Asset Insights, and it provides a single view across the entire Purview data estate. This experience offers insights into the progression of data assets, including how many data sources have been scanned, how many assets were discovered, and how many discovered assets were classified. You can select a classification and view the distribution of assets by source type, such as display all sources with email address or other classification. For file-based assets, like in Azure Blob or ADLS, Asset Insights enables you to take a deeper look into the size of the files and the file types, as well as files not associated with resource sets. This enables you to quickly identify anomalies in data sets, so if you have a particular resource set pattern in an ADLS Gen 2 account, you could use the assets without a resource set to identify files that aren't matching a resource set pattern. You can then drill down to get more information on the assets, such as determine who the asset owner is. Scan Insights, as the name implies, provides a view of the scan progress from the last 30 days. This allows you to gain insights about the scans, understand where scans are failing. This sets the stage for additional insights, so we could drill down into the scans for more information, see the scan names, execution count and time, and then also navigate into scan history to see exactly when scans were run, where they failed, where they were canceled, or where they were successful. The Business Glossary provides a vocabulary for business users to manage the business terms. In this case, Glossary Insights enables you as a business user to understand all of the terms associated in the glossary, count the number of approved or expired terms, and understand the usage of those terms across the assets. Glossary Insights also helps business users complete their glossary by showing terms with missing experts or stewards, and then we could drill down to see which terms are missing that information and navigate over to the glossary to remediate. So we already know that classifications are used to help identify the content of specific types of data in the data estate. Classification insights will help us as, say, a security officer or data steward to understand the types of information found in the data estate, where the classified data is located. Classification insights showcases what sets of assets might contain sensitive information, like, say, credit card information or social security numbers or email addresses. We can then use this report to identify content with specific classifications, and that will help us understand any required actions, such as adding additional security or moving content to a more secure location. And finally, we have the sensitivity label insights. Sensitivity labels from the Microsoft Information Protection Framework lets us classify and protect organizational data while making sure that user productivity and their ability to collaborate isn't hindered. So with Purview, we can view these sensitivity labels on the assets, gain insights into the state of the data, where those assets are, and then we could drill down into the labeled files and see where they're located. And now let's talk about Azure Purview pricing. There are 3 direct costs associated with Purview. There's the Elastic Data Map, scanning and classification, and advanced resource sets, which is optional. The Elastic Data Map is provisioned by default at 1 capacity unit, or CU, with 2 gigabytes of metadata storage. Each CU can support roughly 25 data map operations per second and will scale automatically between the min and max limits based on throughput and storage needs. Each CU is billed at 41.1 cents per hour. For scanning and classification, currently for Power BI and SQL Server on-premises, this is currently free. For all other data sources, it is 63 cents per vCore hour while scanning. And finally, if we use advanced resource sets, so for example, if we have a custom data lake with a complex pattern or frequently changing hierarchy, we could leverage advanced resource sets. This is billed at 21 cents per 1 vCore hour while scanning. Bear in mind that pricing may be different regionally or change over time, so be sure to check the Azure Purview pricing page for up-to-date information. The Azure Purview Data Catalog by default is C0, which allows search, browse of data assets. This is included in the data map cost. For Business Glossary and Lineage, and then also Catalog Insights, these are both currently free in preview. The product levels and feature sets may change as we move through preview. There are indirect costs we should be aware of. So for example, when we deploy our Purview account, there's also a managed resource for storage and event hubs. We might use a private endpoint if we're hosting it within a self-contained VNet. If we're running a self-hosted IR, we might need additional resources for that. And then if we're running M365 information protection for sensitivity labels, we would have that cost as well. And then the possibility of multi-cloud egress charges. So if scanning data in another cloud, there's potential for bandwidth charges. Naturally, there can be quite a bit of variability here depending on usage. So here's a quick example of the fixed costs. If we could look at the data map, if we're only using a single CU, we multiply that out by roughly 730 hours in the month, and that would be a fixed cost of roughly $300 per month. For scanning, we would have to know how many minutes our scans are taking in aggregate. So I have a made-up example here, and then also a snapshot of my Purview account from the last few weeks. And you can see that scanning, in my case, happens to be a very small amount of about $2.36. For a large data estate, that scanning cost could be significantly higher. That sums up this session on data governance with Azure Purview. As a reminder, all of our content is or will be shortly up on the aka.ms/MAA site. We invite you to check it out. Within each section, we'll have our PowerPoint presentations and then also any resources related to the discussions we've had. Thanks for attending and have a great day.